So here I am being all nice again, putting it in bold, right? It's the same as. So the claim is 0.845, P is 0.845. Make that immediately a number, not a percentage that humans made up. Make it a number. Where does that go?
Oh.
Yes. What you call me? P is 0.845. So what's the I got to be?
P is not.
Yeah, P not equal to. So this is a really good example of when you think you know something in science, when you're like, I think it's this. You try to show evidence that it isn't that. Same way in the court case, we presume they're innocent, and what does the prosecution try to show evidence of? That they are guilty. They have to show enough evidence that they're guilty. This is exactly what we're going to bless you. So this is a 1 or a 2-tailed test. Yeah, not equal to means it could be greater or less. That's what not equal to means. So it's a 2-tailed test. Let's get a ghost on stilts. Oh. Can we use z-scores? What do I have to check? What do I check to see if I could use z-scores? I can't do n greater than 30. What is that? I don't want to go there. What is n greater than 34? What type of test is n greater than 34? When I'm testing a claim about a what? About a mean. Yeah, so when I'm testing a claim about a mean, I've got to check to see that n is greater than 30. Here I'm testing a claim about a proportion. What do I check? What do I check? What's greater than or equal to 5? N times P. I love it. And NQ. So NP and NQ have to both at least be 5. We talked about why that was. I love this idea of if you put the picture in the middle, it's got room to go up and go down. That's basically where those came from. It's almost too nice to believe. Those have to be at least 5. What's n in this problem? 322. And P will always come from the claim. We're assuming every time we do a hypothesis test, we're saying, all right, assuming the hoe is right, assuming the null hypothesis is correct, that is the number. Then we go to try to show that that's wrong. Same thing you do in a court case. Let's assume they're innocent. Great. Let's try to show evidence that that's false. That's what we're trying to do in a court case. Or, that's what the prosecution's trying to do. So this would be 322 on 0.845. What's Q? Yeah, so 0.155. I like it. Why don't I use P hat on this step? Because I know P hat is an estimate for P. And then you can say, no, you don't. And yes, I do, because the way hypothesis tests work is we assume this is correct. We assume that P is this number. Beautiful. So what do we get when we multiply those guys together? It's definitely going to be bigger than 5. What do you guys get? I like it. So that's at least 5. And then NQ is going to be, I like it. And that's at least 5. Check. So the beautiful thing about NPQ problems is I never use t-scores for them. T-scores weren't invented for that distribution. Yeah.
What exactly is the significance of
So the particulars of y is 5 is sort of related to y 30. So I can certainly print out some stuff for you to all look at that has the math involved that shows the 5 and the 30. So a lot of it is based on simulations of all kinds of distributions to see about how much it's got to be to make the result normal enough. What's more important than the 5, believe it or not? sort of like that 12 from before. What's more important than the 5 is the idea that it represents. And we talked about, and again, just to remind you guys a little bit, when I have an NPQ problem, I have walls. When I have an NPQ problem, what's the smallest it could be is 0. You have nobody, right? And the biggest it could be is n. And n times p, what is that the formula for? N times p, that's the formula for the mean. And the mean should be close to the highest bar. It actually doesn't have to be the tallest bar, but it should be really close to it. So if the mean is too close to 0, it'll look like this. I really want you to... If the mean was 0.1, if n times p was 0.1, it's going to start tall and go down from there. There's no room for it to go up and then come back down. Does this sound familiar at all? So it turns out that 5, if you make the mean 5 or more, then that's going to give it room to shoot up to that level and then come back down. The NQ part actually has to do with the other wall. Because if the mean became too big, you'd have the same problem where it'd start low and go high and stop. It's got to have room away from both walls, so it's got room to go up and room to come down. Is that semi-decent? The actual particulars about why is it exactly 5? Why isn't it 6? Why isn't it 4.3? The 5 has got a little too much math for most of us at this level. But it's the idea that's more important here. There's got to be some number, it's got to be greater than so that it's in the middle. More in the middle, so it's got room. Hopefully that's familiar. So that means I can use z-scores. It means it's normal enough. How do I get this sucker? What do I need to know? The alpha is 0.10. It's a two-tailed test. I'm using z-scores. So I can still use the t-score chart, of course. Right, because these scores live down at the bottom of that. So what do you get for the z-score for this? What's that related to? What confidence level is that related to? 10% outside is 90%. So it's a 90% confidence interval. Some of you guys might be scared that you remember that z-score is 1.645. I don't know if anybody else is in that. Well, obviously I do. I teach this damn thing all the time. So, right? So of course I'm going to remember those numbers. So it's negative 1.645 and positive 1.645. So, I think I told you guys this last time. I really desperately want this to make sense. In this class, we set up alpha because you don't have an intuitive enough feel for things to make your own alpha. What's your own acceptable level of evidence? You don't know enough shit yet to make your own up. In the real world, when you're doing these statistical analyses, they only report the p-value. Because they're like, different people have their own. So if I had a p-value of 0.04, some people would say that's good enough, and some people would say that's not enough evidence. Right? So how does it work in a court case? Do they tell you how you're supposed to feel so that you come up with a guilty versus an innocent verdict? Do they tell you the level of confidence you have that the person did it or not? I'm 95% sure that he did it. Is that good enough? Well, that's up to the jury. Right? Every jury could come out with a different verdict on every case. It's crazy. You guys semi with me a little bit? I mean, so alpha in a court case, alpha is determined by the jury together. They're not told what it is. You guys semi with me? See, there's no benchmark given to you in the real world about these things. You come up with your own conclusion based on the evidence that's presented. But here we're going to have an alpha. We know exactly how far away is far away enough. So it kind of makes sense. Immediately after we figure out how far away it's got to be, how far away it's got to be to show evidence, we then go see how far away it got. We see if we got enough evidence. So how do we say this in words? If Z star is less than
Major.
or greater than, we can do what? What do we do if we get into that rejection region? We can, who looks to be wrong? If I get way the shit out here, who thinks I'm in here? Which one of these guys thinks I'm in here? Which one of these guys thinks I'm in here? The null. I like it. Why the null? Because he's the one that thinks it equals 0.845. He's the one that thinks it's around that. So if I get out here, it looks like this guy's wrong. He thinks it's supposed to be around this. And if I get way the shit out here, it looks like that guy's wrong. So if I do get way out here, I can reject the null, and I can support the high. Or we can, even better, we say the evidence rejects the null, and the evidence supports the alternate. Are you guys able to step out of the nuts and bolts of this enough just to realize that's all it is? It's just, here's where the evidence starts. Did you get there or not? So now we see where we actually made it. So we know n was 322. X, how many successes did I have? I had 262 successes. So what'd you get for p hat? 0.8? 1.4? That sounds good.
So how did we get Z star 1.645?
We didn't get Z star yet.
Oh,
We got the rejection region.
yeah.
See, why does your, all right, you all know that I'm weird. Why does your weird-ass teacher have a Z star? Because we already have a Z score in this problem. This Z score represents where evidence starts. And the one I call Z star is always going to be what our sample did. So this is what the sample has to do to show evidence that the null is wrong. And this step is what our sample actually did. So Z star is always the one that comes from our sample. So this 1645, it came from alpha was 0.10, and it's a two-tailed test. So we'll look here, two-tail, 0.10, all the way to the bottom, 1645. What happens if I go all the way to the bottom? I get a Z-score. If I stop, I get a T-score. So this chart, they really should have just called it hypothesis test score chart. Because you can get everything and it's set up beautifully for hypothesis test. One, two-tail. Maybe. You guys are so happy. So how do I set this sucker up? My p hat was 0.814. I want to see how far away that is from 0.845. But I have to see how relatively far away it is. Oh, what was it? 322. So that's what that looks like. You have to put that into parentheses if you want to put it all in your calculator at one time. So I get negative 1.54. So right there, we already know the answer. We already know the answer. Did I make it far enough away? Did we find evidence? No. We only made it to a negative 1.54. We only made it right there. We didn't quite make it far enough away. So we're in the area that the null thinks it's supposed to be. That's why we failed to reject it, because we're where he thought it would be. He thinks it's going to be in the middle somewhere. But just to remind you guys, in this problem, our claim was the null, so we're actually kind of happy right now. We were unable to disprove our claim. We actually ended up being really happy. We failed. Yay! How the hell do I find the p-value? What's the p-value? Where's alpha on this picture that I drew? Where's alpha? What is it? What's alpha up there?
Alpha is the area.
Yeah, alpha is the shading, right? That's alpha. Alpha is the area in the tail or tails in your chart. The p-value is in the area of your z-score. Now this is a two-tailed test. I'm going to have to double it. But what's in the area of negative 154? What's the area below that? Negative 154. Can you look up what the area is below negative 154? You don't have a z-score chart. That will be very difficult. So I get this here. 0618. If you double that, what do you get? So this area here is 0.0618. I double it to make it fair because it's a two-tailed test. Now let me say this for those of you who are kind of with me on this. A big p-value, if p is bigger than alpha, that's the same thing as saying that we didn't make it very far away. Now if the p-value, I love you guys, if the p-value is bigger than alpha, that means my z-score's tail is bigger. That means I didn't make it very far away. The bigger the tail, I didn't make it as far away. So we already know that we have not rejected. We failed to reject this thing. Another kind of test you can use is what would the p-value be for this then? I just have to double 0.0618, so the p-value is 0.1236. I'm hoping that you realize that is a huge p-value. That is the probability that that would happen randomly, and that's too big of a probability for it to happen randomly. Okay. So we have not found sufficient. So it's sort of like within a reasonable doubt. And there's too much doubt to say the person's guilty. So then the jury says, we think he's innocent. We haven't shown that he's guilty. And it's shown enough evidence. So that's the p-value. Why did I double this poor dude? Because it's a two-tailed test. That's why. And here's what I wanted to say earlier. What's the first thing we do to alpha? How much is in here? How much area is right there? 0.05. We'll just say this. We could have made the p-value a certain thing and just cut the alpha in half. But they decided to go the other way. They decided to keep the alpha as 0.10 and double the p-value. That's what they decided to do. Could have done it either way to compare those. So one reason why we failed is because that is not less than this. Another reason why we failed is because the p-value is greater than alpha. So what do you conclude? Did we find evidence? Did we make it far enough away? No, we didn't. So we have not found evidence. In fact, what can I say right here? Considering we didn't make it far enough away, we failed to reject the null, failed to support the high, and I'm going to use that language because that was our claim, was the null. Failed to, so we have not found sufficient evidence to reject the claim that, let's see, what did it say? The proportion of professors who think, percentage of profs think it is impressive is 84.5%. So we did not find evidence to say that it isn't that. Say again? Yeah, we didn't find enough evidence to reject the null hypothesis. But when you make your conclusion, I don't want to see anything about hypothesis. I want to see what the claim actually was in English. That's how the guy would want, they hire you as a statistician, as a consultant. You're not going to come back to them and say, we failed to reject the null. What shit's that mean? What about my claim? Maybe. All right, so let's do this. Is everybody decent with that? You guys have any questions from that? I mean, most of the time, most people get the nuts and bolts of this down. This is all built on stuff we've done before. What people trip over is how to word the conclusion, but it ain't that hard. Which one was my claim? HO. So which one of these am I going to use? This one. Failed becomes we have not found evidence. To reject and so forth. Okay. All right. Let me do this. Let me show you what's going to happen. If there's no more questions on this guy. A lot up there. What I want to do is, I'm sure you guys have seen this. If you ever saw Ghostbusters, at least the original, I don't know about the new one. You saw cars that look like this, right? Have you guys ever seen these? Put them all up here so you see what they look like. Nobody's ever seen these? Here's the bacon. Where's the last one? We got we're supposed to find. Where'd you go? I got a star. Oh, I forgot box. Okay. How many of you guys have ever seen those images before in some sense? No, this is amazing. Okay. Maybe, well, it's just a different generation. So the way this works is, the way I'm going to have you guys do this is I'm going to pair you guys up. One of you is going to have the cards. All right? There should be 20 little cards in the little pack I'm going to give you. The other person is going to have their back turned to you, so they can't see through. Right? That's kind of, what is that? You're going to pick a card up and you're going to think about it, and then you're going to, I think maybe just tap them on the shoulder so they know you have a card, and then they guess what it is. You guys semi with me? And you just go through the whole deck. So if they get it right, you make a mark on a piece of paper. You have a little tally running. Are you guys with me? I want to know at the end, out of 20, how many did they get right? So first we'll do that. We'll see who gets the most out of 20. And then we'll do a claim. We'll test that claim that they have ESP. And if somebody has if the hypothesis test comes out saying, yeah, it looks so, we'll retest that person. Right? Or those people if I have a tie for highest. You guys kind of with me? A little bit? No? You guys have no idea? All right. Let me give you the card. Let me first off, let me break you guys up.
First just got the
Okay. All right. Let me see, how should I do this? I think I'm going to break you guys up first. Let me see how many I got. 2, 4, 6, 8, 10, 12, 14, 16, 18. Did I lose somebody? 4, 6, 8, 10, 12, 14, 16, 18. Okay. I was excited for a moment. I thought I'd be able to participate, but there's an even number, you guys, so I'm just going to observe. Huh? I understand. I won't take a break. These things happen. So let me see, we had 18, so let's see, I want 9, Bruce. So just count to 9. Say 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 9. Good. 1.
1,
2.
6.
How do I do this? You missed it.
Oh, I'm sorry. You're 9. Sorry, Jay.
It's okay, I'm used to being forgotten.
Oh, come on. They didn't forget you. We all had you, man. All right. So find your person. The ones. Try to get somewhere away from other people so that. Where's my 1s and my 2s?
Assemble.
And then I'll give you a little packet.
Sure. Start off. All right.
I'm Dave.